Alright, the objective for 5.2 is I can describe the relationship and extend terms in arithmetic sequences. And so first we have to go over some definitions. The first one is a sequence. And a sequence is an ordered list of numbers. So we're going to fill in an ordered list of numbers. So it's a list of numbers, but the order they're in is important. And then the next definition is a term. A term is each number in a sequence. So the first term is the first number, the second term is the second number. And we usually use n to represent the number of terms. So if n is 1, that's the first term. If n is 2, that's the second term. If n is 40, that's the 40th term in the sequence, or the 40th number in the sequence. And then our last definition is an arithmetic sequence. So an arithmetic sequence is a sequence where the pattern is adding. So we're going to add the same number to each previous term to find the next one, where the pattern So if the pattern is adding 3, your sequence might be like 3, 6, 9, 12, 15, 18. We're adding 3 every time. So all of our sequences today are going to be arithmetic. That means the pattern is always an adding pattern. Some of the problems that you're going to have to do are going to say to describe the relationship in the sequence, and then find the next 3 terms. So describe the relationship in the sequence, then find the next 3 terms. So for our first example, let's say the sequence is 6, 9, 12, and then we know it continues. So first we have to find the pattern, or describe the relationship. And I know it's going to be an adding pattern. 6 plus 9, or 6 plus what will give me 9, and 9 plus what will give me 12. I notice that it's adding 3. So the pattern is adding 3. And then I need to also say the next 3 terms, so the next 3 numbers in this sequence. So 12 plus 3 would be 15. 15 plus 3 would be 18, and 18 plus 3 would be 21. So I've done both parts. I've described the pattern, and I've given the next 3 terms. Let's do another one of these. So for example 2, we'll do 12, 17, 22, 27. The first thing we have to do is describe the pattern. So I think 12 plus what is 17, 17 plus what is 22, and it has to be the same number every time. So it's going to be adding 5. My pattern is adding 5. Then I need to give the next 3 terms. So after 27, 27 plus 5 would be 32. 32 plus 5 would be 37. 37 plus 5 would be 42. And those would be the next 3 terms. Okay, let's do one more of these. The third one will be 20. Let's do 20, 24, 28. 32. So we have to say the pattern on this one is adding 4. Oops, let me move it up. So the pattern is adding 4. The next 3 terms would be 36, 40, 44. Alright, there's one more type of problem that you'll have to do, and the next type of problem is to write an expression that can be used to find any term in the sequence. So I'm going to move this up so I have more room to write. It'll say, these ones will say write an expression to find the nth term of the sequence. Nth term . So if n is 1, it's the first term. If n is 2, it would be the second term. If n is 16, it would be the 16th term. And what if n is 50? We don't want to have to write out all 50 terms. So we're going to use an expression to figure out how we could just plug in 50 for n and then figure that out quickly. And then let's find the 40th term. So for example 4, let's say the pattern is 5, 7, 9, 11. So this is how I write my pattern, and this will always work. I first figure out what the pattern is, and on this one, my pattern is I'm adding 2 every time. And then I look for what would have come before this whole sequence started. If I added an extra term here before this whole sequence started, what number would go there? And in this case, it would be a 3, because 3 plus 2 would be 5. And I'm going to use those to write my expression for the sequence. The pattern will always be whatever you're adding here, so in this case it's a 2, times n, so times the number of terms, plus the number that came before the whole thing started. So 2n plus 3 in this case. Because, let's see if that works. If n is 1, I should be getting a 5. That's the first term. 2 times 1 is 2, plus 3 is 5, so I got the right thing. If n is 2, I should get a 7. That's the second term. 2 times 2 is 4, plus 3 is 7. If 2 times 3 is 6, plus 3 is 9. 2 times 4 is 8, plus 3 is 11. So that works for this term. Then to find the 40th term, I'm going to replace n with 40. So I have 2 times 40 plus 3, which is 80 plus 3. So I know the 40th term would be 83. I don't want to have to write out all of those terms to find it. Okay, let's do one more of these. Let's do, for example, 5, 33, 37, 41, 45. We're going to do the same thing here. First I'll look and I'll see what my pattern is. And I'm adding 4 every time. So I know it's going to be 4 times n plus whatever came before. So if I added an extra term before the whole thing started, this would be a 29, because 29 plus 4 is 33. So it's going to be 4n plus 29. And then I'm going to use that to find the 40th term. So I'm going to do 4 times 40 plus 29. 4 times 40 is 160, plus 29 is 189.